Welcome to the Science Olympiad Coaches Workshop for Optics this year. Before we begin, a little introduction about me, maybe. Okay, so my name is Maria Blake. I am a postdoc at Oak Ridge National Laboratory currently. This is my third year working with the Science Olympiad, second year doing optics. Last year was interesting and fun doing the first year of optics since what was it, 2017? If people remember, I don't know. So this is my second time leading the optics events, and I'm very hopeful that it's going to be even better than last year. So as I said, I'm currently a postdoc at Oak Ridge, but I did receive my PhD just in May from here, University of Tennessee. Thank you. And I graduated from the chemistry department, and I like to say that my degree is actually in optics. So I home built a lot of the instruments that I used to study how small molecules interacted with bacterial membranes. So it was super fun. And even now, as a postdoc, I am working on building more instrumentation to study abiotic and biotic interfaces. So super fun. And then my future goal is to actually become a professor at a primarily undergraduate institution. So education and optics are two of my greatest passions. So I'm really excited to be here. So before we jump into the optics events, I kind of would like to take this time to get an introduction from you all. And if you've done the optics event before, what your experience has been like for the optics events. And anything that I can do to make it better than last year. Because I know there were some good things, but also some bad things about last year. So I'm open to all comments, concerns, questions about it.
Kristen Brown, chemistry, for Magnet Academy, clean slate. This is my first year. And it's been motivating. I'm excited about offering them. I know. Rosters later. I'm Stacey Arthur. I'm an LNN Staff Academy. It's second year of Science Olympiad. So while I did these last year, it was just overall night I was constructive to.
Yeah.
I'm Emily Stafford. Teach AP and honors chemistry and have a new STEM program this year. And so this is our first year ever doing this. And so I know nothing. And this has been eye-opening. But awesome group of kids that just are taking this on and running with it. So they know more than I do. But I help out Tracy when still feel like I like to help out. And I'm Rebecca Cindy, also at Northwest, also not a similar. But I did protein science with chemistry and biology at Bureau High School. My kids have done optics, but same. I was too overwhelmed to know exactly what's going on. So.
Carol, I'm a med, and it's my third year, but this is also third year science. Just in science, they did optics last year. The STEM teacher last year, he made the box and everything. So they have something to use and play with. They kind of get the gist of it, but I'm still not all with it.
Okay, this year we actually have something that I used last year.
Right.
So I know last year we yeah, last year we did our best with what we had. But this year we have the one that's from the Science Olympiad. So we're gonna play with it today. But disclaimer, I don't like it. The way that the laser sits, I hate it. It doesn't sit straight. And I had to jimmy it a lot last year. So I had to like take some materials from the classroom and like stack it under the laser. So that way, like if you press it. Yeah. This year I'm gonna get my husband to build it and make him do something. Yeah. So I didn't like that. And then you'll see whenever we come up here, the bottom of it completely rusted. Over the past, what was it, 6 months that we've been apart. So I'm gonna build it this time, and I think it's gonna be better. But dimensions obviously will be the same. So that's yeah.
My name is Becky Cutter. I'm also at Web. I've taught for a long time, but this is my first year at Web and my first year in science. Yeah, I teach engineering and robotics. Yeah.
You have an engineering and robotics class? Wow.
Yeah.
And I'm probably at school for, 15, 16 years, and here I am in 5 minutes.
Wow.
8th grade, oh, I didn't say 8th grade physical science. So my physical science is like a 9th grade level class is what I teach.
That's cool.
I taught 9th grade physics for their school, and she does. It is 9th grade. I'm Tracy Anderson. I teach middle school STEM. I started out in science, and I've been in science Olympiad since year 2001. And I serve on the board of directors here, and I actually joined the board when I was working with the Murfreesboro. And started teams, and every school I started a team in, only one is still continuing. That's why I'm in Murfreesboro. But yeah, I taught high school and middle school. But anyway, I'm your coach for East Tennessee. So. But with optics, when my son, who's now 28, when my son was in, I don't remember if he was in 8th grade or the 9th grader on my middle school team, but we won gold and silver in optics because I took a Saturday and I had him in an enclosed space and fed him pizza. And we spent 4 hours going through the practice tests and because all these kids were math kids, so they had an understanding of angles and geometry. So it was real easy to translate that and then tell them all the other stuff about light and color and, particles and waves and stuff, because I just come from teaching high school physics and not knowing what I was doing. 3 hours in science, but still, yeah, but went through it with them, and they worked out the box and stuff, and I got gold silver. There's my
And how to use the angles and do the papers or the templates. That's where I'm at. They can know how to use that.
We didn't do that. They did string. They had string and the tractors, and that's how they did it.
Really?
Yeah.
So I'm a big string girl. I use strings like every single day in my jobs because I'm like,
They just said, okay, it's gonna hit here. And
let's put a mirror there, and
I
then
wanted to go here. So
Yeah.
where should we set it? So they laid the tractor down to get angles and laid it set it down.
yeah.
But how they worked all that out, I probably should sit my son down and see if he remembers.
Yeah, well, if you do, let us know. Okay. Well, thank you all for sharing. I think we only have one person online. I didn't know if they wanted to share anything. Obligatory 2 seconds. 1, 2. Okay. Okay. So today, the outline is we're going to go over the event parameters. I'm probably going to just speed through this a little bit. It's not very different from last year, but it is slightly different. In my opinion, I think it's for the better. I think that the rules read a little easier this year, and they're a little bit more intuitive. So we're going to go over some changes. And then a brief introduction to optics, basics, and the resources. And then we'll play with the box that I brought. And then that will leave room for questions, comments, concerns. And last year we didn't have a lot of time to go over any kind of example questions. So I have the questions from last year's Jeopardy style presentation. So we have that if there's time or interest. So with that being said, for the written test, a lot of this is the same for B and C. The only difference for the written tests are not very easy to see, but the colors in blue, those are going to be for C. And then plus all the ones in black. And then for B, it's only the ones in black. So for the written test, they have a minimum of 20 minutes to complete it. However, it's a 50-minute time slot, and I let the students just sit down and work on the test until their team is called up to the front to work on their box. So they have 50 minus 4 minutes to work on it all. So, minimum minutes. They are allowed to bring in a 3-ring binder with any information from any source. So they have sky's limit for resources. They can bring in whatever they want. They can bring in things that are in little plastic sleeves, so little templates or like fold out things, as long as it fits in that binder. They're allowed to bring in some tools, templates, supplies, writing utensils. So if you think there's a clever way to make a template for the written portion, you can. I don't think that there really is, but if there is, feel free to share. Any kind of supplies, any writing utensils. They're able to bring in 2 calculators, class 3, and look that up. That is just an advanced calculator. So they can bring in any calculator they want. 2 of them. But they are not allowed to bring in any kind of lasers, mirrors, optical devices, or electronics. So everything will be provided for them for the laser shoot up system. So they won't have to bring in anything on their own for that. So for the test itself, it's going to be a mixture of multiple choice, true, false, completion, and calculations. But I will say for B, this year, the rules have said, or they have stressed that a lot of the questions, like the open-ended questions, are more qualitative than quantitative. So keep that in mind. This year, it's going to be more qualitative. But there will be some simple ones, but nothing crazy. And then at least 5 questions for each of these topics, and it's a lot of topics, a lot of details. So I would highly recommend that the ones that are easy to show in a picture, so like color theory, structure and function of the human eye, pieces of the microscope, telescope, insectants, structure and function of cameras, glasses, these kind of things. I would highly recommend that you have printouts of those, so that way you can easily just flip to the picture of it and fill in whatever information the exam requires. So those are the ones I would probably recommend spending the least amount of time learning and more amount of time being able to find the resources to answer those questions. Because those are just labeling, filling in the blanks. And there's a lot of good tables and charts out there for the things like the diseases, optical problems in the human eyes. So I would spend the most amount of your time going over the math, geometry, and qualitative interpretation of reflection, refraction, mirrors, and lenses, and absorption. That one especially is going to take more thinking. It's not as clear cut because you have to work your way through those kind of problems, where the other ones, it's looking at a resource and like being able to do those quickly. So I've learned that Science Olympiad is a lot of working smarter, not harder. So yeah, that would be my advice for the written portion. Do we have any questions about this portion so far? I have one more slide over the math expectations. A couple of new ones from last year. I think the optical concepts related to information storage and retrieval and DVD media. Full disclosure, I don't know what that means yet. Didn't get my PhD in that, so we'll see. That's about. But I think that's the only one that's like brand new. The other one, I think that they had just like separated like the diseases in the eye and the functioning structure of the human eye.
So would you say the C test is heavier on math than just concepts, or is it about equal, or?
It's definitely going to be heavier on the math. Yeah. Yeah, I will say, the way that I structured it last year, because this is so many concepts, 5 questions per one. A lot of these are going to be true and false, and multiple choice. A lot of them. For the like calculations or labeling of diagrams, free responses, that's going to be the ones that's like the reflection, refraction, mirrors and lenses, those kinds of things.
Southern, state, and national only. So, for regional,
For regionals?
Yeah.
I don't think so. Let me.
Under section 3, part C, and then C7 says state national only for those last 7 topics, so then regionals only goes up to.
I will say ideally, state and regionals are supposed to stop there. But if you can work a little bit in their binders, just in case they miss that and they throw some extra questions on the test, it kind of separates the ones who just learned what they had to learn and the ones who really have to grasp the concept. So it just reduces the risk of ties. So sometimes they'll throw extra questions on there just for fun. So if you've got the time to throw in the state topics just for fun, it's helpful.
Yeah.
We found that.
Nice. And there do have to be tiebreaker questions. And I feel like the meanest person in the world whenever I make these tests, because like I have to make them so hard so that way there's not multiple like 100 sitting around. Like there has to be a clear winner. It makes me feel so mean though, because I'm like, I couldn't even make 100 on this test. These are high school and middle school students that take this so seriously. So no, I'm not out there to hurt your children.
so what's there from like you see
Not a lot that is super math intensive with optics. So a lot of optics, it's really subtraction and addition. Because it's a lot of like, honestly, all the math just stems from the law of reflection. There's going to be some refraction. That's a little math heavy whenever you have to take into account Snell's law. So index of refraction and the angle. But that again is a little bit of simple algebra with like, I want to say it's a trig, but it's like sine of theta that you just type into it.
Trig and Snell's law and all this stuff on the middle school. Snell's law, critical angle.
Oh, was that so also full disclosure, I didn't do the B test last year. I only did the C test. I had a partner in crime for the B. So Snell's law wasn't on B last year.
It wasn't, it's in boldface. That means it's new this year. And another one, simple trigonomic, it's for regional. Simple trigonomic relations to enable the use of trigonometric functions on a calculator. No angles and radians, so that's nice. So.
Yeah, that would be mean. That would be mean. I don't even work in radians, so.
So now I gotta teach my middle school kids basic trigonometry. Never heard of it before? Just seeing the little letters. Yeah, I've seen it. Wow.
Yeah, this then. Yeah, so I would say it's honestly not that math heavy. The hardest math is simple trigonometry. And it's like,
Which is
sine.
smart kids, but.
It is, yeah, especially it's like you don't have to go down the whole rabbit hole of it. Honestly, sine is enough. Sine and inverse sine. That's all you really need, math wise. But yeah, reflection or refraction, that first bullet point is going to be the most math heavy. Yeah, and the other ones are mostly qualitative. You're gonna have to do some ray tracing for mirrors and lenses, but I find that a lot of people find that pretty intuitive, without having to think about math. So, yeah, the first two bullet points are gonna be the most math intensive. And then for C, for the state and national absorption spectrum, maybe. But I already have a fun question for that one. I'm not allowed to tell you. Yeah. Any other questions about the topic of the written portion? So with that, the math expectations, just basic geometry, basic trigonometry, and algebra, solving one equation for one variable, and then for high school students, solving systems of equations for multiple variables. And then, as I said, division B, there's not going to be a lot of math for the free response questions. If there is, it'll probably be a multiple choice just for the sake of time. And it's, yeah, so mostly qualitative and just ray tracing for those. Okay, now the fun part, the laser shoot. So the objective of the laser shoot is to use the mirrors that you're given to work around a barrier to get the laser to be as close as possible to the target that's on the opposite side of the laser. So I'll show you guys the box whenever we stop with this. So they're able to bring the same exact things that they were able to bring for the written exam. And so they're able to bring a 3-ring binder, tools, template supplies, writing utensils, calculators, not calculators, but nothing that actually is used in the laser box, like mirrors or lasers themselves. So timing is going to be super crucial. I would spend a lot of time working with your teams to be as efficient as possible, trying to get the barriers on there. Because I think that's where a lot of it, we struggled a lot last year, was with timing. We also only had 2 boxes for the 50 minutes, and it was 4 minutes, and then we tried to get grading under a minute, but it was very difficult. So this year I'm going to build 3 boxes, so that way we can have a little bit more leeway with time, because it was a little stressful trying to get all the teams to go up. But the way that I did it last year is I had all the teams sitting, doing their exam, and I would start from one side of the room and call 2 teams up at a time to do it. And so the teams would always know who's next because I would go in the order that they were sitting in. And so I would always, whenever I would pull up a team, I'd be like, you're next, like, be prepared to stop in about 4 minutes. So everybody gets a heads up that they're about to go up. So it's not like, okay, stop taking the exam, get down here. So I try to be really like nice about it, and give them some time to mentally prepare themselves for it. And then after they're done with the laser shoot, they're able to go back and keep working on their exam. But they do only get 1 shot to do the laser shoot. And like I said, we only have 4 minutes, and we grade with them there because we write it on their exam, what their grade is for the laser shoot. And we try to walk them through it. Another thing that I did last year that I think I'm going to stick with this year, because it's hard to announce the rules and directions to a big group of middle school and high schoolers. I'm sure you all, yeah, have to repeat yourselves the rules and things. So I just did the rules every time a group would come down. I'd be like, look me in the eyes. And I think that worked. There was only like 1 or 2 teams that were like, I didn't know there was a target. And I was like, what? There was there was a 9-year-old I thought was about to fight me last year. Like, she was mad. They finished their laser shoot and they said, yes. And I said, your team's there. It's like 3 points. And she was like, what do you mean? I was like, so yeah, a little traumatized from last year, but we'll get it. You're mean. You're some mean ones. Yeah, they really do. They're so serious about it, which I totally respect. Like, yeah, go for it. But I repeat the rules every time a new group comes in, so that way it's very clear. There's no miscommunication. I'm like, do you have any questions for me? And they're always like, no, I'm ready to go. And I'm like, okay. So that is something I do every time with every team. And so they will be given a total of 4 minutes for every single team. We have to say 3, 2, 1, start. And then we give them a warning whenever 3 minutes elapse. What I made my volunteers do last year is I made them put a timer on their phone and set it down on the table. So that way the team could actually look at the clock. So it's very transparent how much time they have the entire time. And then minutes, and as I said, we try to get the grading done in about 1 minute. So that way we have 5 minutes per team. But with 3 boxes this year, I think we can take more time explaining it if they require it or want it. So hopefully they can have more feedback to come back with if they didn't get the score they were hoping for. So they have the 4 minutes unless one of the members of the team removes a barrier from the mirror, then their time automatically stops and I have to grade with what they have. So that was another thing that they did not like. They really wanted to take off the barriers. They're like, how am I gonna do it? So no marking or modifying the laser box itself, no adhesives on the box itself, and then no touching the barriers at all. So they're not allowed to touch the paper that's on top of it. They're not allowed to move it. They're not allowed to do anything with it. And if they do, they get a penalty and then a time deduction for however long it takes me to fix it.
You glue them down, Velcro down or something barriers,
So
so they don't inadvertently hit them. Like, I can see that happening, like, oops, it fell.
There was one team, they were like, I don't like that there. I was like,
But I would do like Velcro sticky or something.
yeah, so they all have
Oh, magnet, that's what you're talking about, rusting, right?
this is bad. It's silver. Awful. I made it clear by putting the tape over, so we'll put the mirror, they can see side is the like which one has the reflection, if they look down on it. How about here?
I've seen mirrors on stands and they were not covering them because you don't have a laser.
Really?
Maybe, but that was, like I said, I was 10 years ago.
Yeah.
So
Yeah,
it was a
you
brand
have
new,
to
it was
have-
fairly new event. Because we were really excited with laser shooting.
Sounds super cool in theory. So I'll talk about this whenever we get to like the tips and tricks a little bit more. But one tiny change in an angle, so if you're 1 or 2 degrees off, the further away, it just gets amplified with space. So it's really important that you establish the first early mirrors as precise as possible. And whenever you get closer to the target, the more leeway you have. They could be a little silly willy with it. So yeah, and so for the templates, I don't think it worked all that well for the teams that had it. And I say that because you can never predict where the barriers are going to be or the target. Yeah. So
Like the Post-it notes you suggested last year, they have like the pre-drawn.
I would highly suggest the Post-it notes or even
Like that. It's not.
I mean, it is. I mean, like there were students that had like full, like giant pieces of paper that they would put over it and they would cut at the table to go around the barriers and things. I think it took way more time than they had time for. And I think they had to rush a lot, because they were trying to get the templates perfect. Yeah.
Sorry, what were the Post-it notes?
So last year I recommended that you get Post-it notes or index cards and you put in some common angles. So like a 45 degree, 45 degrees. So you know that if the laser comes in this way, it'll come out this way. And you put that on top of your mirror and you know where it's going to go. And then from there, you can take your string and project where it's going to go. So I would recommend something closer to that than trying to get graphing paper and making large templates. So it's going to be really hard and time consuming to get it working with the barriers and mirrors that you have. Yeah.
So then,
Of the barriers? I would think, I'm imagining, have it, like, let's just say this is a giant version of your Post-it note, and you draw maybe 45, 45. Then you have some. You say, okay, so it's gonna come in this way. And I want the laser to come this way, so I'm setting the mirror here. And so now I'm gonna take my string and I'll follow the other angle and see where I need, where the next mirror is gonna go. Put it there, and then to use the Post-it notes to actually draw the angle it's coming in on.
Yeah, you can.
And then get the Post-it note and quickly use your protractor and draw the other side and say, okay, so now I'm gonna take the string here. I think that's what my son did.
Yeah.
They use the
You
string.
can bring like scraps of paper and put it in the laser box itself. Keep in mind though, that if you put something on it and you put a mirror on top of that paper, we have to keep the paper there to grade it. So if it's like not perfectly flat and is making it kind of ankle weird, just keep that in mind. So I would just practice over and over and over again to make sure that the materials you bring don't interfere with the efficiency or with the laser path itself. I would highly recommend like smaller templates that are, you can easily adapt with the barriers that you do have. And then, so this year, they included a really nice drawing, which I really appreciated. And I think they also made it easier to get points. So it was super demotivating last year whenever I had to sit there and say, I'm so sorry, you have 0 points. This year though, they're counting if you go over what's called these grid lines. So they get points for every line they go over. That's exciting. So they can see points. So for instance here, the laser will hit your head. And so if you had a Post-it note, what I would recommend is saying, okay, you know your laser is going this angle from here to here on the dotted line. So you have your Post-it note that has the angle. You say, I want to put mirror B here. So to get from this point to this point, I need an angle that's and so for here, the point grading system would be 2 points for crossing this grid line and the top grid line. Then you would hit mirror B, mirror C. You cross 1, 2, 3 grid lines. And then you get points from C to the barrier mirror, 1, 2 grid lines, and then barrier mirror to D, you cross 1 grid line. And then from D to the target, you go. So you get all of those grid lines added together, and that's part of your score. And I have a scoring thing on the next slide, so we'll go over
The
that.
second place team said we used all right angles, which basically meant all 45 and 45.
Yeah.
And set their mirrors accordingly.
Yeah, and honestly, this simpler the better. Don't try to be super complicated with it. Just if you stick with like 45, 45, you're pretty guaranteed to get close to the mark. The steeper the angle is, the more variability you're gonna have. So if you're trying to hit it at like a 60-degree angle or 70-degree angle, it's going to matter a lot where that mirror is sitting. Or else like it's gonna go all over the place. And I saw that a lot with teams, but they would think that they were just raising the mirror to get it to go where they wanted it to go. And they would go like against the wall opposite the target. So yeah, I would stick with smaller angles. So like 30 to 40 degrees, 30 to 50 degrees. I don't know why I said that. 30 to 50 degrees is going to be the sweet spot. I wouldn't try to do anything risky. Use all the mirrors. Use the barrier mirror if you can. Yeah. And then the dimensions are the same as last year. So if you did have one from last year, you can use the exact same one this year. Everything's the exact same. Yeah. Any questions about the setup itself? And I would recommend making it yourself. I'm pretty sure the ones that are on the website are like stupid expensive. They're like $100 or something. They're great for that. My husband could have made that for like $50, less than $50. So yeah, I'd recommend making it. Okay. So for the scoring, the total score at the end of the day, it's going to be 45% from the exam, the written test, and then 55% from the laser shootout. So this is a little different from last year. Last year was 50-50. This year there's ever so slightly more weight for the laser shoot up, and I think it's because of the grid lines that they can get more points that way. And I will say last year, the points were bad for the laser shoot up. They were not great. So a lot of the times the teams that won and got like the most points are the ones that excelled in the laser shoot up, because honestly, they scored pretty similarly on the exams. Like you get more variability in the laser shoot up score than you do for the written exam. And I think that's a large part because you get so many resources for the exam that for a lot of the questions, you can look up a resource to answer the question. So I would recommend spending a lot of time practicing the shoot up itself. And then trying to, like I said, work smarter for the exam if you can. And really dedicate time on practicing the setup system. So for the written exam, I think this is new. I don't think that they did this last year where it was normalized to the highest grade. I don't think that was a thing last year, but I could be wrong. I don't remember. But this year, the test score that they get is going to be divided by the highest exam score of all the teams. Which will also be a little morale booster. Their score will be higher. By normalizing it. And then multiplying by 45. And then for the laser shoot up system, so they're going to get a score for the line score. So every grid line that they cross, they get some points for it, divided by the highest number of all teams. And that's going to be 20% of the laser shoot up system. So worst case scenario, they get nowhere near the target, but they go through so many lines. They get tons of points for it. You can get up to like 20 points. So, and then for the accuracy score, so it's going to be from 25 minus how far away they are divided by 10. So if they're 25 millimeters away, they're going to get 0 points for it. So a lot of the times, if they end up on another wall, they're not going to get points. So if they are in a time crunch, I would train them to, worst case scenario, just get it on the wall the target is on, because they will get some points if it is on that wall. So if they're in a time crunch and they only have 30 seconds left, they have 2 more mirrors, they give up the mirror, just put it on the wall. That's probably. Also barrier score. So they get 10 points if the barrier mirror is used. That's 10% of the score. Any questions when it comes to the scoring? It has to be on the opposite side and it has to be along the ruler. So on the opposite side of the laser, there's gonna be a ruler that's mounted. And you'll see it on here whenever we come out to the front, but I have a piece of paper that goes all the way from top to bottom of the barrier wall, across the ruler. Yeah, I think actually the barrier or the target was kind of big last year, so they had room for it. Not super big. I was being dramatic. It's it's just like 2 or 3 millimeters. It's not that bad. But yeah, it's a piece of paper on the opposite side. Yeah. Any other questions about the scoring? Okay, tips and tricks. So the items that might be useful. So if you don't have an index card, honestly, the tractor is like a cheater's index card. You don't need to draw out the info. Really, the index cards are a really good reminder that the incident angle is always going to equal the protractor that it's a little lost. Sometimes, and I'm guilty of this too in the lab, I'm like, oh, this will go that way for sure. If I did it this way, that's on the wall. Are better than a protractor, so that it's a solid reminder that it's like always going to be equal. But if you have a clear one of this, it's really nice because you can put it against the mirror and you can get your string and see where it's going to go. So these are nice. Your mirror. You can touch your mirrors all you want, as long as you don't take off that mirror. There, you can move the mirror if you want. Oh, yeah. There. A ruler. I would recommend a ruler if you don't want to bring in string. That's kind of the same purpose of like, okay, it's gonna go this way or this way. But I will say you have teams of 2. So if you don't want to bring a ruler. Oh, also, if you were here last year, these are things students want. So if your students were like, oh, I love my calculator in optics, this is nice. If not, gladly keep it. I threw it all in a box and put it in my desk. All right, for next year. So yeah, rulers would be nice. Post-it notes, note cards for the pre-made templates would be nice. String, and then for removing the pieces of paper, like I said, I think I'm gonna keep it this way. I like this. I like that there's extra room. Don't have to touch the mirror themselves to get this off. This feels really easy. Loved, so they're kind of easier. I love papers, not easier, so. I think I'm gonna keep it this way, and you can see the reflective side. That was the thing a lot of them struggled with, is they were like, which sides are reflective? And I was like, this side, see it. But some people didn't pass. They just assumed. And then they wrong side. Felt so bad. I felt like a villain last year. It's rough. So can't sit there and be like, you're doing it wrong. So if they aren't super comfortable using their hands and fingers, because recommend cardboard for the official rules. This is good. I like the paper, so I'm gonna stick with it. More tips and tricks. So this is just an example that I had last year. So this is just the law of reflection, knowing that your incident angle is always going to be equal to your reflective angle. So keeping that in mind and really drilling that into your students' brain. But always remember that. Like I said, in the moment, it's so easy to convince yourself that you know better than the law of reflection. So So, and also remember that it's always in respect to the normal. And the normal is going to be that 90-degree angle surface, so the mirror surface. We only have about 10 minutes. I want to get to this. I'm not going to go through this or these example calculations unless you want them, but this is also going to be available to you. And then my email's in the PowerPoint presentation. So if you have any questions or concerns or anything, feel free to reach out to me. And I will get back to you. And yeah, so just in case this is recorded and you don't actually have the presentation, I'm gonna click. You can pause. Okay, so couple of resources. I think that this one is new. I don't think that this wiki page last year. Because whenever I was looking up resources to put on here, I found this, and I wish I found it last year. It is super helpful. I would print out that entire page and put that in your binder. Super helpful. It has all the definitions you need, bolded, italicized, like super easy to read, super easy to flip through, has pictures, it's organized really well. Wiki page for optics. Highly recommend. All the other ones, there's lots of YouTube videos, which are really nice. I'm sure there's even more now since it was an event last year. So that's another thing. Pro of last year is that there's a lot more resources out there this year than there was last year. So these are all the ones that are on the Science Olympiad website. If you go to the first link, they also have a list of resources. But then these are resources that they do not say. That just from working in an optics lab, these are ones that I find really helpful. So if you go to a lot of like optics suppliers websites, you'll find a lot of informational tutorials and videos, information in general, such as Edmund Optics, Newport, Thor Labs. They're really nice. Edmund Optics is very advanced, but I find myself referencing that over and over and over again in my day-to-day when it comes to simple ideas. So it might be something that you want to go through and then try to dump down a little bit because it is very advanced, but it's very nice. And then Nikon's Microscopy View, they have a lot of like interactivity things for the microscopes and lenses and things. The Colorado website, that's interactive, and I think the physics classroom is too. Yeah, so that's all I had for the presentation. There's Jeopardy. But once again, there's no time for that. Like classroom. So, and then that last few minutes, come up and look at this and we can go over. Any questions before we break into chaos with the. Any questions online? Yeah, it came with it.
Did you do that or did I?
No, it came with it. I don't like it.
It's still, it's
It's
not enough for such a long.
yeah, it's so.
Wow.
It went so much. So last year, this is what I.